Okay, happy Monday or Tuesday, whenever you're watching this. We are going to do a second part of simplifying radicals. You guys were pretty good with just the numbers, and some of you have it down pat, but I just want to practice more. Um, just the skill I saw with the variables, and the numbers I want to go over, like the misconceptions or where some people oversimplified when they saw a perfect square. Some people didn't know what they should do with the variables. So when you take the square root of exponents, so when we have our variables x, y, z, and whatever we have, and it's raised to an exponent, um, if it's an even exponent, we just divide the exponent by 2 to move x outside the radical sign. So if you have a perfect square, like 100, sorry, not perfect square, an even exponent, so 100, 16, 12, they're even numbers, you can divide them in half. That's going to be the square root value. Because think about it, when you multiply a to the sixth by itself, the exponent rule is that you add the exponents when you're multiplying. So this goes back to a to the 12th power if we were to go like check our work kind of thing. So when it's an even exponent, all you do is take half the exponent and you get rid of the radical. So some people, let's say we're looking at this one, some people still kept the radical x to the 50 and then they kept like simplifying it. Don't do that. So once you take the square root of it, you get rid of that radical sign, okay? And then because it's just going to keep simplifying, you're not going to get the right answer, okay? If it's an odd exponent, so if we look to our right on the screen over here, so we have 7, 15, 27 as exponents. What you do is you're going to subtract 1. So when we have x to the 7th, then we turn this into x to the 6th and just x, right? X to the 1st kind of thing. Divide even exponent by 2. So if we have an even exponent, again, we're allowed to take half of it. We can take the square root of it by taking the half of the exponent. And then you leave that other variable under the radical. So if I have x to the 7th, I would turn into x to the 6th, x to the 1st. X to the 6th is even. We can divide it by the exponent divided by 2. So the square root of x to the 6th is x to the 3rd. We can't simplify x to the 1st, so we just leave it under the radical, okay? Sometimes you will have a radical still in your answer, and that is okay. Don't think that everything can be like square rootable. That's not really a word, but that's what I'm going to say. The other problem, you have n to the 15th, which means you minus 1, so you have n to the 14th, and n is like kind of like the breakdown of n to the 15th. Take the square root of that. You can take the square root of n to the 14th because it's even, so it's n to the 7th. We leave the radical n there because we can't simplify that. Okay? So hopefully this helps you with simplifying. We're going to do a few problems. Some of them are on the homework or the class assignment that's due on Tuesday. Some of them are just mixed examples. So if you listen through, you'll probably be able to do some of your assignment problems with me and like check them. Some of them aren't on there. So this one, we have 300 and x squared. So basically what you want to do is do separate. So you want to separate the number from the variable. That's what I like to do at least. All right. So think to yourself, what can we break down 300 into where 1 is a perfect square? Remember your perfect squares. Sometimes it's easier to write them down so that you have something to reference. I know like when I was in class, remember you guys saw these on the wall because we were doing them in geometry as well. So you guys are learning the same stuff. And again, it's good because you're going to learn this next year. So maybe you'll be ahead of the game. And I'm bugging out here. 49, 64, 91, 100. Okay. So think about what goes into 300. Which one of these can go into 300? But make sure it's the biggest perfect square. So maybe like 25 can go into 300, right? If you think about like money, like quarters. But the biggest one here would be 100, right? And then what two numbers make 300? 100 times 3. Okay, these are still both under radicals, right? We haven't taken the square root of anything. We kind of just are branching it off, simplifying it. So the square root of 100 is just 10. So we have 10 radical 3 so far. Then think to yourself, is x squared a perfect square? Remember, anything that has an even exponent you can take the square root of. So If you divide 2 by 2, it's 1. So square root of x squared is just x. So then to combine these, remember this is still multiplication. So your final answer is going to be 10x radical 3. Okay, and the x goes in the front. It goes where like the 10 would be because we took the square root of x squared. It's just x. It's not radical x. If it was radical x, we'd put it here. But we're putting it in the front of the radical because it's already simplified. Let's try another one. So we have 5, which is on the outside, so we're going to keep them here for a sec. Let's just break this down. Think to yourself, radical 32, what can we break it into? And then square root of c to the 4th. Well, 4 is even, so this can simplify to just c squared. Right? Just divide that exponent by 2. Square root of 32. So some of you are probably thinking, oh, like 8 and 4, right? Makes 32. So you could use 8 and 4, and I'm going to show you what happens if we use 8 and 4. So 4 is a perfect square, so we get 2 radical 8, but you got to think to yourself, can 8 be simplified more? Can we simplify 8? Can we take, is there a perfect square inside of it? There is, so you can do it this way, it's just going to be longer. So radical 8 can still be simplified to radical 4 and radical 2. There is a perfect square inside of it, radical 8. So this turns into radical 4, radical 2. Square root of 4 is just 2. Can you simplify 2, radical 2? What's the square root of 2? Is that, like, doable? No. If you put that in the calculator, it's a decimal. We don't want decimals. We want perfect squares. So if you did it this way, you now have a 2 and a 2 on the outside, just dangling out there, and you have a radical 2. So what you have to do with these two numbers is multiply them together. So then you have 4 radical 2. You have 4 on the outside. Radical 2 is still under the radical because we can't simplify it. And you still have your c squared, and that goes in front because it's already simplified. So your final answer is 4c squared radical 2. If you said, well, 32 is 16 and 2. That's the biggest perfect square. That would have been less work. Using the biggest perfect square will make your life easier, but it's not wrong if you use different, simpler numbers. Okay. This one is on the homework. This is number 2. So again, think about, are these perfect squares? Are they even exponents? If they are even exponents, all you do with the exponents is divide it by 2. So yes, they are both even. So these are square root, you can take the square root of both. So 2 divided by 2 is 1. So we have x to the first. And then 4 divided by 2 is 2. So we have x to the first and y squared. Nothing is under a radical anymore because they're both, we can take the square root of both. Okay, everything's simplified. This one is number 3 on the assignment. So we're going to leave 10 out here. He's just dangling for now. So let's do this first. We have radical 20 and radical x cubed. So let's do the variable first. This is odd. So remember, if it's odd, we can't just half it. It's not square rootable. We got to simplify it. We got to subtract by 1 first. Remember the first slide I showed you. So we have x. We can break this into x squared and x to the first, right? Because 2 plus 1 is 3 as the exponents. Okay, simplify the perfect square. The square root of x squared this is our perfect square. This turns into x. We can't take the square root of x, so we just leave it like this. So we have this part. And let's break up 20. So 10 and 2 can work, but our 10 and 2, or one of those a perfect square. Remember, one of them has to be a perfect square. So which perfect square goes into 20? 4. So radical 4, radical 5. Simplify radical 4 to 2 radical 5. So we have these two terms to have. But remember, you have this 10 out here. So what do you do with numbers that are just kind of outside? I call them the dangling numbers, which is not really mathematical, but you multiply them together. So we have a 10. You multiply it to the 2. And we have this x out here. So all these terms are going in front. So we have 10 times 2 and x, which is 20x. And then under the radical, we have the 5, and we have an x. So then I'm going to put those 2 there. So we have 20x, radical 5x. And if you do have questions on this, while you're doing it, email me. Don't just guess, I'm online, so Give me some time to answer if I don't answer right away, but I am available. All right, next one. This is actually number 4 in the assignment, so I'm doing a lot with you, so hopefully you guys are watching this video. All right, so again, and you have to show all, some of you may be able to do this in your head and you have to show all work, but so we have radical x to the 7th, and then we have radical y to the 8th. Which one's a perfect square? Which one has an even exponent? This one. So all we have to do is half the exponent. So the square root of y to the 8th is just y to the 4th. This one's odd, so remember we have to minus 1 from it. So you have x to the 6th and just x. Because we want one to be a perfect square, so this turns into just x to the 3rd. And we're left with x to the 3rd radical x. So all together, we have this term to multiply, and we have this term, which are both not under a radical. And then we have these two, and this one, sorry. And the y to the 4th is not under a radical. And then we just have this one that is under a radical. So let's combine all the reds. They go in front, right? They don't have a radical sign. So 4x times x to the 3rd times y to the 4th. Remember, when you multiply exponents, you add them. So this is x to the 4th, y to the 4th, and then inside the radical is just the blue, which is the x. The x is the only thing that we couldn't simplify out of this problem. So that is your answer to that question on the homework. And let's see, I may have one more. Oh, and that's it. Okay, so you guys are going to do the rest. So remember, take the steps. You can separate the numbers and the radical and the variables. You can do it all at once. It's up to you. Look out for some being evens, which they are perfect square. Don't break them up if you don't have to. Some of you on the homework I saw something like this. It was a square root of 36, and then I saw like this. So careful, the square root of 36 is just 6. It's not, you don't put anything under the radical, so don't, like some people are breaking it up. But careful, that's not, don't do that because it is a perfect square. So anything that is a perfect square, square root of 64 is just 8. Square root of 49 is just 7. So don't like separate them out if you don't need to. All right. I think I was trying to think of other stuff I saw in the homework that some people were just getting confused about, but that was really it. I wanted to just review more of the variables. And then on Wednesday, I'll post us doing a lesson on quadratic formula, which is getting us back to finding solutions. There are also 3 multiple choice problems on here. I won't stress you showing your work for them. You can just tell me the answer, but it's whatever. For the 7, I'd like to see work shown. All right. So you guys watch this video, and I hope you guys had a good weekend, a good Easter, a good Passover, whatever you celebrated. And we'll talk soon.